Uh, okay, I'm actually using my software to record my video, and before later I'll send you. I think much more better than the Google Meet. Alright, I will send to all of you. So basically that we have these equations, dx which is equal to dx and the dy bar plus dx bar and n dy and dw and dy dy multiply the dy bar and plus dx multiplied by dy and multiplied by w and plus d and so on of the equations. So now we have two d flip-flop which dx and dy. Yeah, from here that we know that bar we need to use not get and also plus which we all need to use or get, and also we have an input signal w, right, and AND get here we need AND get which has two inputs, and AND get which has three inputs. Now we back to the Quartus software. You can see the Quartus software. Actually you just need to click the new project and then just go to the block, click onto the block diagram or the schematic file and then click OK. So it will generate a new file. This new windows we're going to pop up just like this. But of course it's empty. Alright, it's empty. And then how are we going to start to insert the components from here? So just click onto the components here. Alright, there's components here, and actually they will be blank over there. You're going to see the window something like this. So just double click onto this, alright, expand the folder, and you can choose the components that you want from the primitives or the others, but mostly the components that we need to use it, which is from the primitives. So we have an input. So normally we use pin. Alright, pins, which is W. You can see from the equation we have W's. So actually it's input. We have input and also with the output. So we can add in the input. Alright, the input name. We can modify the name later on. Alright, and also we have the output. Alright, we have the output. Yeah, and again that we need storage, normally d flip-flop, which is a storage, right? So which is d flip-flop. So this d flip-flop actually we have jack flip-flop. You can see we have so many different d flip-flop here. Latch, which have latch is to hold the data. Alright, we have enable. Right, this d flip-flop and the other flip-flop. So we just choose the d flip-flop. So then we have clock, and then we have enable. So I think we no need to use an enable. Alright, so just choose on this d flip-flop and you place two d flip-flop here. Alright, place these two d flip-flop. After that we can choose the AND gate, logic gate. So logic gate is here. So choose the AND gate. 2 means that there are two inputs. If we have three inputs, we choose the N3. That will be the three inputs. And then we have a NOT gate. We have a NOT gate. We have OR gate. Right? So choose the OR gate and the NOT gate here. This is a NOT gate. After we place those components from here, then we need to construct the circuit based on these equations. Alright, these dx equations and the dy equations. Yeah, so you can see it. Alright, now this is actually I constructing on this dx. So we can see that this is a dx bar multiplied by dy. Here actually is the output of the d flip-flop dx and the output of the dy bar. Dy, there's no bar, so we need an inverter. I'm working on this. So dx bar, you can see that the output of dx. Double click on this d flip-flop. There's a Windows pop up again. Then we just change the name of the flip-flop to dx, right? Dx, and click OK. The other one as well, we just double click on the flip-flop and just name it called dy. So after that we can do the interconnection based on these equations. So we have an input here. Alright, this is an input. So double click. Alright, there's default VCC. The name will be, I'm going to give W. Alright. So this is input, W. So I input a dy. So we need another dy signal. Okay, done for the first one, which is dx bar, dy, and w. Next, I'm going to do dy bar and the dx. So from here, so which is this is a dx. Alright, so we need the bar for dy. Just copy, right click on the components, copy, and then right click and paste the components that I want. So there's no gap. Alright, just we can join the connection from the first completed AND gate. Alright, and make sure that you can see there is a bubble here, the circles. That means there is a connection between this line and that line. Right? Make sure there is no short on W. This W line, there's no there's bubble, no dark bubble, in between the line. So that means there is no connections. So this is correct. So there's connection. So done. So this of the complete of the circuit exactly similar to these equations. Right, so the next, I hope that you can follow what I have completed in dx, use the same concept and the same procedure to come out with the dy. Right, the dy, which is the input from here. Right, this is a dy, you can see. So what you can do, that we can see how many the OR gate we need on this. I think we need 3 inputs, 1 set, 1, 2, and 3. 3 inputs of the OR gate. So actually we can go to get another OR gate which has 3 inputs. Alright, click on the logic, find all the way all 3. You manage to see all 3. Yes, you can see all, which has 3 inputs. So this is all the 3 inputs. And yeah, I press over here, right? So this is the output name. Output name I'm going to put outside here. So we align it in tally so that we can, it looks like much more synchronizations, organized, much more organized. So this is a, yeah. Okay, starting then you can connect the other 3 set of this. 1 set, 2 set, and 3 set. They are all of 3 input AND gate. Alright, so you need to duplicate a 3 input OR gate. Alright, so I hope that you are happy with this tutorial and try to complete the connections.